So welcome back to the second session. We'll have a quick recap on what has been discussed in the previous class. So in the previous class we gave a brief introduction to the course, and we also looked into the overview of analog and digital electronics. So we have looked into what are the topics that are to be discussed under analog and digital electronics. We also geared up with digital electronics, and we recalled what was done in your basic electronics. And just to recall, the main concept in your in this particular module is to simplify a given Boolean expression. Earlier in your basic electronics, you had looked into the concepts of Boolean algebra to simplify a given Boolean expression. Now in this course, more advanced graphical approaches have been introduced. So we took a generic way of simplifying a given Boolean expression. That is, we applied two theorems one after the other. That is, we first step was to apply the uniting theorem. So if there is room for further simplifying the expression after repeatedly applying uniting theorem, by applying consensus theorem, we would simplify it and keep the result. So but the drawback was, one, it led to different solution. Different pair of combinations gave me different solutions, and each solution may not lead to a minimal solution. And to overcome this, we have advanced approaches which includes graphical or map approaches, which includes Karnoff map, Quen-McCluskey method, and Petrik's and map entered variable techniques. So in today's class, we will see what exactly Karnoff map is and how it can be applied for simplifying a given expression. And also we will start with how to write a K-map. We will I will brief you about the steps involved in solving or simplifying a given expression using K-map. Later we will introduce a term called as don't care terms, and how to deal with don't care terms in simplifying a given expression using K-map. All these things we will discuss in today's session. So we will start with a K-map. On the first, we will discuss how to plot a K-map. Later we will see how to apply these K-maps for simplifying a given expression. So we have a K-map, which we call it as graphical method or map method for solving a given expression. So before we get into the details of K-map, we will first see how K-map is written for a given expression. Say you have a two variable expression, we will write a K-map containing 4 cells. So in general, if there are n variables, we write a K-map comprising of 2 power n cells. So we will start with a simple case. We will start with a case of 2 variables and see how a K-map is plotted. We will extend it for 3 and 4 variables later. So we will consider 2 variables. So if you have 2 variables, the number of cells is 2 power 2 is equal to 4. So 4 is the number of cells used in representing a K-map, and let me call these 2 variables as A and B. So if you write the truth table for this particular case, your truth table looks something like this. We have A, B, and let me call the output as Y. AB happens to be the input and Y happens to be the output. So we have all possible, we'll write all possible inputs 0, 0, 0, 1, 1, 0 and 1, 1. So we have, these are all the possible combinations of inputs for 2 variables. And I will just, at this point, I am not worried about what the output is, because my intention is to write a K-map for a 2 variable expression. So there are 2 ways the authors they choose to go with representing in their own convenient way. I will just show you how to represent either ways, and we will try to go with one of the 2 representations. So you can have A on one side and B on the other side. So, I end up getting, because it is 2 variables, we end up getting 4 cells. So, these are the 4 cells, and first comes here A bar, and then comes here A here, B bar and B. So, this is representing 0 0. So, this happens to be 0, and this is representing A bar, B bar. So, this cell is corresponding to this entry of your truth table, 0th entry of your truth table. And now this is A bar B, this is corresponding to this combination, that is first entry of your K map. So, I will make a small marking here to indicate what cell it is corresponding to. This is corresponding to 1, and this is corresponding to A B bar. A B bar is the 3rd entry of your truth table. So, I will mark it as 2. It is representing min term 2, and now we have A B. So, A B happens to be the last term, and this is representing a min term 3. This is one way of writing the K map. So, this is M naught, and this is M1, M2 and M3. So, we can map it. So, based on what terms are present in your Boolean expression, make the corresponding entry as 1 and the remaining entries as 0. So, we will take up how to make entries into these table later. So, or otherwise you have one more way of representing this table. I can interchange the positions of A and B. So, you can write the K map this way also. First comes 0, then comes 1, A bar A, here also B bar and B. This ends up again giving me a 4 cell K map. So, this is representing 0, and now in this case this is representing 1 and this is representing 2 and 3. So, if at all you are given with a 2 variable expression and asked to solve a K map, simplify the given expression using K map, you can go with this or this representation. And the author of the reference textbook we are referring is following this convention, this representation. So, we will go with this convention. If you are convenient using this convention, that is also permitted. Either use this representation or representation. I strongly recommend you to go with this representation, because the reference book we are referring to is using this particular representation. We will consider K map using 3 variables. Let me call the 3 variables as A, B and C. We can again write the K map either using this representation or that representation. Here I have taken A on one side, BC on the other side, and when you go with this representation, we take A here and BC on the other side. So, here we write all possible values of A, that is 0 1, BC 0 0 0 1. You please note, it is not 1 0 and 1 1, it is 1 1 and 1 0. Here again it is 0 1, all possible values of A is 0 and 1, 0 0 representing B bar C bar, 0 1 representing B bar C, this is BC and BC bar. Again here 0 0 0 1, 1 1 comes first and 1 0 goes next. So, accordingly this is 0, this represents 1, this represents 2, this represents table 3 entry, 4th entry from your table. This is 4, 5, 6 and 7. Again this is 0th entry of your table, first entry of your table. This is second entry, this is 3rd entry from your table, and this is the 4th entry, 4, 5, 6 and 7. So, this is how you write K map for a 3 variable expression. This is A bar, B bar, C bar, and this is A bar, B bar, C. This is A, B bar, C bar corresponding to third min term M3. This is corresponding to min term M2, min term M4, min term M5, M6 and M7. So, you can either go with this representation or this representation. I recommend you to go with this representation, since we will have a uniformity in solving all the problems. So, this happens to be the 3 variable K map. So, we will take up 4 variable K map later. So, we will try to solve, we will try to apply K-map and simplify the given expression using K-map technique. So, first we know how to write the K-map. Now, I will just list out the steps used for simplifying the given expression using K-map and take few examples and illustrate how K-map can be applied for simplifying a given Boolean expression. I will try to brief the steps involved in solving a given expression using K-map. The first step is to write the K-map, which we already know. So, we will extend this for 4 variable expression, taking 4 variable expressions later. So, first step is to write the K-map corresponding to number of variables in a given expression and make sure your expression is in sum of products form. So, once you write the K-map and make sure and convert your expression to SOP form, you make entries into the K-map, you mark all those cells with 1 whose terms are present in your Boolean expression. Mark the entries into the cells whose terms are present in a given expression as 1 and rest of the terms as 0. Once it is done, you try to identify the adjacent ones present in the K-map. Try to group them as pairs, quads or octet. Always look for the larger group. So, this is a step, the third step involved. So, once this is done, you try to eliminate the variables in every group. So, we will try to, I will just write the steps involved in solving the K-map and then later we will take up an example and try to solve a given expression using K-map technique. These are the steps involved in simplifying given expression using K-map. So, the first step is make sure your expression is in SOP form or otherwise you convert it into SOP form so that things are simpler for you to make entries. And once that is done, you write the K-map comprising of those many cells depending on the number of variables you have in the expression. Once that is done, you make the marking into the cells. So, you just consider the function is mapped onto the K-map by marking a 1 whose min terms are present in the equation in the expression and those mark a 0 for all other terms. And after that your minimization consists of identifying the groups of adjacent ones. You try to look for adjacent ones which could be a pair, quad or octets. Always try to identify larger groups. When there is a possibility of making an octet, think of making an octet instead of a quad, instead of 2 quads. And if at all you have a provision to identify a quad, instead of considering 2 pairs, identify quads. After that you can overlapping is also allowed provided a variable is not included in any other groups. So, after this you try to eliminate the variables looking into these groups. We will better understand this when we take up an example, few examples and solve this. But when I say overlapping is allowed, make sure you are identifying the prime implicants. So, if it is not possible to group any term in any other groups, try to include it in one of the other groups or overlapping the groups. So, that is where I mentioned overlapping of groups are allowed. So, we will try to demonstrate this with an example. So, we are given with a truth table which is representing a given Boolean expression. Your problem can be given in different ways. So, here one of the ways is you are given with a truth table asked to simplify using K-map. So, we have truth table representation and you can see now I will try to identify the min terms here. 0 1 0 corresponds to 1, this corresponds to M2, this corresponds to M4 and this corresponds to M6. Once you have identified the min terms, we will write a K-map. K-map I have already written for you. So, because there are 3 variables, we write this particular K-map. We are writing a K-map comprising of 2 power 3, that is 8 cells. A on one side, BC on the other side. First comes 0 and here 1, 0 0, 0 1, 1 1 and 1 0. So, this is corresponding to min term M0, M1, M2, M3, 4, 5, 6 and 7. So, you look into this table and just mark a 1 to all those cells whose min terms are present in the given truth table, and all other cells are marked with 0. So, here we have M2, we are marking M2 as 1, we have M3, we have marked M3 as 1, M4 we have is present in the truth table, we mark I, and M6 is also present, we mark a 1. So, all other cells are marked 0. Now, we try to identify groups. So, groups here are adjacent ones, always look for larger groups. So, here I find 2 ones. Had a 1 been present here, this would have formed a quad, because there is no 1 here, this 2 forms a pair. I identified this as a group. And please note here, this is a pair, but this will be left out. Please consider these two again form a pair, because you can just imagine a piece of paper here. So, because if I consider this corresponding to this particular 0 and 4, and this bottom of the paper corresponding to 2 and 6, and if I roll down the paper, what happens is 0, 4 and 2, 6, they come together forming adjacent cells. So, I can consider 4 and 6 as the adjacent cell and form them as pairs. So, I can call this as a pair. Now, though it is possible to make 2, 6 as a pair, it is not a prime implicant, it is not essential, because 6 has already been included in this group. We will not consider this 6. So, redundant groups are to be eliminated. So, we consider only 2 pairs. So, we will try to eliminate the variables here. Please note, when I form a pair, one variable is eliminated. Similarly, if I form a quad, 2 variables are eliminated. On the other hand, if I form an octet, we tend to eliminate 3 variables. So, that is why I asked you to look for a larger group. Here we do not have any provision to form a quad or an octet. So, what we do, we end up getting 2 pairs. So, we will try to eliminate the variables. So, I will consider this pair. So, when you consider this pair, we will write only those terms which are common in both the cells. If you look into A appears as 0, 0 here, that is A bar, it is corresponding to A bar, I write it as A bar. And when it comes to B, so B is I here and B is I here, I write B as B. And when it comes to C appears as C and here, and in this cell it appears as C bar, we cannot take it as common, we will take only A bar B. That is where I say when we form a pair, one of the variables will be eliminated. Here I have written, here only literals A and B are retained, eliminating C. So, that is where we have A bar B. And if you consider this pair, so if you consider this pair, again we will consider A is common here, A is common. So, it is 1. So, I like this literal in an uncomplemented form, that is A. Now, consider B, and B is 0 here, it appears as B bar here and it appears as B here, I cannot take it as common. And coming to C is C bar, 0 here, 0 here, C bar, it appears as C bar. So, this is common here. So, this expression reduces to this particular expression reduces to only AC plus A bar B. So, in its original form, it comprised of 4 product terms M2, M3, M4, M6. Now, it has only 2 product terms, and that too each product term has only two literals, AC and AB. Here B is eliminated and here C literal is being eliminated. So, the one which required more number of gates in its original form requires only 2 AND gates followed by an OR gate. So, that is where we use K-map for simplifying the given expression. So, we will consider a few more examples and try to solve using Karnaugh map approach. We have one more example here wherein the expression is given directly in terms of in min terms. This same expression can be written in terms of max terms. There is no much thing to do. So, when this is your min term representation where it is sum of products summation m 135. The shorthand notation for writing this is 135. If you want to convert this to an expression, POS form, just it is complementary. So, you can write it as product of sum. So, whatever terms are missing here, we include it here. So, it happens to be 0, 2, 4, 6 and 7. So, I will just directly map this onto the K map. So, because it is a 3 variable expression, we use literals A, B, C. We have written K map comprising of 6 cells, 8 cells, A on one side, B, C on the other side. 0 comes first, 1 comes next, 0, 0, 0, 1, 1, 1 and 1, 0. So, we will try to mark all those min terms present in your given expression onto the K map. We have 1, we have 3 and we have 5. So, rest of the cells we will mark it as 0. Now, try to identify the groups here. I can form a pair here, and since this, if I lift this out, no variables will be eliminated. So, we can consider overlapping this with this particular min term, thereby we end up getting 2 pairs. So, we will consider this. So, here what is common? A bar is common, and here we have B bar plus B. B bar plus B ends up becoming a 1. So, we will eliminate. So, we will not consider this, and we have C. So, it is C. So, this particular pair ends up being A bar C, and here we have A is not common here, A bar plus A, it ends up being 1. So, we can eliminate it. Since it is not common and it ends up being a 1, we will not consider it. What else is common? B bar is common and C is common. We will write it as B bar C. So, our expression reduces to A bar C plus B bar C. So, we will consider few more problems before we take up 4 variable expression, before we deal with don't care expressions and K map expressions. Okay, we have a typical example here. So, please note here, it is not, though it is in sum of product form, it is not in standard SOP form. So, why we do not call it as standard SOP form is because if you notice, it happens to be a 3 variable expression. In the first product term, all the 3 variables are present, all the 3 literals are present either in its complemented or uncomplemented form. This is accepted. But here if you see, literal A is neither in its complemented nor in uncomplemented form, that is literal A is missing, and if you look into this, both B and C are missing. So, I can call this as expression as, though I can call it as SOP form, it is not in standard SOP form. So, when you have such representation, you may find it difficult, you may find it difficult in mapping this onto your K map. One step is to convert this into standard SOP form by multiplying each literal with the missing term and its sum of a missing term and its complement. So, your A is missing, so I try to multiply with A bar, because since A plus A bar ends up being 1, multiplying something with 1 does not make any difference, and here B and C are missing. I try to multiply with B bar, which ends up to be 1, and C bar, which ends up to be 1. Multiplying this with 1 and 1 does not make any difference. Or otherwise, if you want to avoid this step, that is avoid step of converting the given expression into standard SOP form, then make a mapping. So, we can directly consider mapping this, that is more easier, or if you find difficult, you can just convert it into standard SOP form and then make a mapping onto your K map. So, you just consider A, B, C bar. A is high. So, this is this particular row corresponds to an AI, and B, C bar. So, B is I and C bar. B, C bar happens to be this. So, this is B, C bar and this is A, B, this represents A, B, C bar, that is corresponding to 6, I mark a Y. Now, consider B bar C. So, B bar C is 0, 1 this is your cell and it is independent of A. Since it is independent of A, whether A is 0 or 1, this is an I. So, I will mark 1 to both the cells here, because it is not dependent on A, whether A is 0 or 1, but main thing with this term B bar C should be I. So, along this row B bar C is I, so I mark a 1 here. And considering this A bar, so all along these cells A bar is I, so irrespective of values of B and C, A bar is I, so I will mark all these cells as 1. So, this is one way of mapping your expression in incompletely or unstandard SOP form onto the K-map, or you can include one more step here, multiply each term with sum of missing term and its complement and convert it into standard SOP form, then mapping becomes straightforward, you can do it, or you can directly map it onto your K-map. So, rest of the cells remains 0. So, I will mark a 0. Now, try to identify the groups here. So, you can see 4 adjacent ones, a group of 4 adjacent one forms a quad. So, I can identify this as a quad, this becomes a quad. Now, consider these two, this is a pair, because I cannot even, if I consider this as a single one, number of no variables will be eliminated. So, overlapping is allowed. I can consider pairing this with this adjacent one, this becomes a pair and this also ends up becoming a pair. Now, what is common here? A bar is common and here B C bar is common and here B bar C is common. So, we end up getting this expression. So, A bar plus B C bar plus B bar C. So, though it is 3 terms, in one of the terms the 2 literals are missing. A bar is as it is and this literal one of the terms has been eliminated, A has been eliminated. So, this is how you we have dealt with all the 3 cases, given a truth table, how to map onto the K-map, given an expression in min term representation, how to map onto the K-map and simplify, and given an completely or a sum of product which is not in standard form, how to map it on K-map and solve. So, we will now go with the next step, wherein we will try to consider 4 variable K-map. We will extend the same to 4 variables. So, when you have 4 variables, the number of cells which are to be considered as 2 power 4, 16 cells. We will take few examples of 4 variable expression, how to write 4 variable K-map and solve using K-map. So, we have a 4 variable expression, we will call it as ABCD. So, we need to write a K-map comprising of 2 power 4, that is 16 cells. So, we can consider writing AB here and CD here. You can follow the other order as well. So, this corresponds to A bar, B bar, A bar B, AB and AB bar 0, 0, 0, 1, 1, 1 and 1, 0. So, likewise, here also we have different combination of CD 0, 0, 0, 1, 1, 1 and 1, 0. Accordingly, this particular cell corresponds to M0, M1, M2, M3, 4, 5, 6, 7. Here we have, because it is swapped, AB comes before AB bar, this is 8, 9, 10 and 11, this is 12, 13, 14 and 15. Now, I have taken an example here, we are given with a 4 variable expression. We will try to map this on to the 4 variable K-map and try to simplify it using the technique, K-map technique. So, we have we have min term 1 is present, mark here 3 and 4 is present, 5 is there, 10 is there, we have 12 and 13. So, we end up getting a K-map something like this. So, all rest of the terms I will mark as 0. Those min terms which are present in the expression, mark corresponding cells are marked with one I, and those which are not present we will mark an I. Now, we look for adjacent ones. You can see 4 adjacent ones, they form it forms a quad, and here it is not possible for me to form any quad here. I form a pair here, and as I already said, towards the end if you have two ones, they form adjacent ones, and I can consider forming this as a pair. So, what we have identified is, now we will not do this because this has already been a part of this pair. It is going to be redundant term, it will just add one more product term which we need to eliminate. So, this is a pair, we have identified two pairs and one quad. So, and if you look here, what is common, we will consider those. A is not common, it is A bar plus A, it is eliminated. We have B, and if you look here, D bar plus D, it is going to be eliminated. We end up getting only C bar. So, as I have already told, if you identify a quad, two variables are eliminated. Here we are eliminating D as in the A. So, here we have a pair. So, what is common in this pair? A bar B bar is common. If you consider this pair, A bar B bar is common, and coming to C bar plus C becomes 1, which is it will be eliminated, and D is common, I will take it. So, and in this pair, A bar plus A gets eliminated, and we have B bar and C D bar. So, we end up getting this expression is going to be reduced as B C bar plus A bar B bar D plus B bar C D bar. So, try avoiding the conversion to uppercase, because I had written it in uppercase, I have written it as uppercase, or otherwise you use lowercase letters to have proper representation. So, this ends up giving me this particular value. 2 I have missed here, consider 2 also. So, this happens to be the solution for this particular expression. So, with this we will come to the end of this session. Today's session we have discussed how to simplify a given expression using K-map. So, we considered 2 variable K-map, 3 variable K-map and also 4 variable K-map. So, in the next session we will introduce one more concept, don't care concept. If at all your expression comprises of don't care terms, how that is to be considered while simplifying a given expression we will consider, and we will also try to summarize whatever we have done in the form of a flow chart. So, we will whatever we have discussed, the steps involved in solving the K-map, we will draw it as a flow chart and try to discuss, because that is with respect to examination point of view, that is important. We will see how to represent the entire procedure of applying K-map in a flow chart representation, and try to discuss that. With this we will end for the day. Thank you.